Okay, today we're going to do the notes for section 4.1, and we are going to solve a system of equations by graphing. Okay, a system of equations is simply two or more equations with the same variables. Graphically, the solution to a system is the point where x, y, that's the point where the two lines intersect, the point where they cross, the ordered pair. Algebraically, it's the point or the ordered pair that makes both, this is both, the equations true. So if you plugged in the x and the y into both of the equations in the system, it would work for both of them. Okay, these are types of solutions. So when you have intersecting lines like this point where they cross is going to be one solution, and you'll have the coordinates to that solution, or the coordinates to that point, and that'll be your solution. If your lines look like this when you graph them, railroad tracks or parallel lines, they're never going to touch, so this is no solution. If they're the same line, plotted one on top of the other, then you're going to have an infinite number of solutions, or all real numbers. My infinite sign is terrible. Let me get to another one. How about this? Better for you? Okay, so here are the steps to solving an equation by graphing. So the first step is you're going to, let me get a color ink you can see, is rewrite the equations in slope-intercept form. In case you don't remember what that is, it's our friend y equals mx plus b. Then you're going to graph both lines. And then you're going to identify the solution or solutions. All right, let's see how this goes. Let's just do one together. Purple. Okay, so here's our system. We have y equals 8 minus x and y equals negative 2x plus 1. Luckily, those are already in slope-intercept form, so all we need to do is graph them. So let's graph y equals x minus 8. We're going to start at negative 8 on the y. And then our slope is 1, positive 1. It's important to draw these lines as straight as you possibly can. Using a ruler is optimal so that you can identify the appropriate solution. Okay, now I'm going to graph y equals negative 2x plus 1. Here's my 1. My slope is down 2 over 1. Let me go back. Okay. Not the straights. Okay, so here is where they cross. So the point where they cross will be 1, 2, 3. That's my x coordinate. Down 1, 2, 3, 4, 5. So 3, 5. That's my solution. If I were to plug, sorry, it's negative 5. If I were to plug that into the equation, both of them would work. All right, let's try the next one. So they're both in slope-intercept form, so I'm going to graph the first one, starting at 9. On the y-axis, my slope is positive 1/2. There we go. And then I'm going to graph the other one. So it's up 6 on the y. And my slope is -1, so down 1, right 1. Up 1, left 1. So here's our solution. The coordinates to that solution are -2, +8. So if I plug those points into both those equations, your equation would work. All right, let's go to number 3. We have to get these into slope-intercept form, so we got to move them around. So here's my first one. I have to get y alone. So I'm going to add 3x. So I have y equals 3x plus 8. Let's get the other one there. Got to get y alone. So I'm going to add x to both sides. So I have y equals x minus 2. All right, let's graph. So I'm going to start with +8. And my slope is 3. Now I'm going to start with -2. Slope is +1. Got a ways to go before you actually meet up here. So my solution here is the coordinates of the point where they intersect. And that'll be negative, can't really see the purple, -5, -7. All right, I'm going to pause here and I want you to try the next one. Move them around to slope-intercept form first and then graph both of them. Now actually, I'm going to do this one with you. This is a weird situation. I'm going to go, I'll stay with white because I have to move them. So the second one's in slope-intercept form. Let's move the first one around to get y by itself. I'm going to subtract x. I'm going to put a 1 there because when we divide each side by 2, this will be -1/2 x plus 2. And look at that. The equations are both the same. So you're going to graph one on top of the other. Let's just graph this for grins. If I were to graph the other one, whoa, let me make a better line for you. If I were to graph the other one, it would be exactly the same thing. So it would be right on top of there. So it would intersect at an infinitely number of points. So this is infinite solution. Okay, so why don't you go ahead and do 5. Take a second and do 5. Okay, if you put the first one into slope-intercept form, you get y equals -1/3 x. And the second one is a horizontal line going through -7. And then the point of intersection there is 6, -7. All right, let's do the next one together. So the first one is in slope-intercept form already. So let's go ahead and graph that. So we start at 5, and our slope is 1, so up 1 over 1. Got to do the other side, so -1, -1, that gives us a positive slope. Now let's move the other one around so that we get it to slope-intercept form. I'm going to subtract x from both sides, so I have -y equals -x plus 2. We still have that negative signs there, so we have to divide by -1. Y equals x minus 2. So let's graph that one. If you notice, when we rearranged, these have the same slope. Lines with the same slope are parallel. These are never going to touch. So the solution to my equation is no solution. There is not a solution. So it's no solution. There you go. We have 2 more to do. So these both need to be put into slope-intercept form. Let's rearrange this one. So I'm going to subtract that 3x. I have -5y equals -3x minus 35. Then I'm going to, divide by -5. So I have y equals, a negative divided by a negative is a positive, positive 3/5 x plus 7. All right, let's go over here. We have 2x plus y equals -6. This one's a little simpler. You're just going to subtract that 2x, and I have y equals -2x minus. So let's go ahead and graph. So my first one starts at 7. And I'm going to go up 3 over 5. Do the opposite here. Pretty good line there. All right, my other one starts at -6. And your slope is -2. So down 2 over 1. Up 2, left 1. Gotta go a long ways before we meet here. There it is. Here's our point of intersection. So our solution is -5, -4. That's the coordinates of the point of intersection. All right, let's rearrange that second one. I'm going to subtract 3x. So I have -2y equals -3x minus 18. And I'm going to divide by -2. Okay, let's go ahead and graph. So I have x equals -2. So that's going to be a vertical line going through -2. And then I'm going to start at 9. I better extend this. And then I'm going to go down 3, left 2. Both negatives together make a positive. So there's my point of intersection. And my solution is -2, 6. That's the coordinates for that point. Okay, that's it.